Hello, welcome to another session on Heron's formula. Herein we'll be taking a few application questions of Heron formula. Let us first write down the question and then I draw the figure. It says Radha made a picture of an aeroplane with colored paper. As I will be drawing the figure, you can have a look at how the aeroplane is drawn. We have to find the area of the paper used. It says find the area of the paper used. Let me draw it first, because it's a aeroplane. Just be drawing with some straight lines so that it looks more or less like an aeroplane, sorry. Okay, this looks. Let us also draw the wings. Okay. The lengths of the sides which are marked, I'll just also be noting them down here. It is 5 centimeter. This is given to be 6 centimeter. This is again a 6 centimeter given. This whole length is supposed to be 6.5. They're all in centimeters. This length is 1 centimeter, even the other side also the same length. This is given to be 2 centimeter and this one being 1.5 centimeters. I hope I'm not missing anything. We have to find the area of the paper used to make this structure. To do so, let us divide the whole figure into few small areas. Suppose this one I mark. Let us mark this as area 1 so that it helps us when we find out the areas for these different segments and then we add them all. That is 1. And now I will also segregate this from here, thereby making this area to be 2. This small here in becomes 3. I can mark these as 4, maybe this as 5, and the rest. Is anyone left? No. Let us now find the area of this region 1. I write it here. It's area of region 1. Now area of region 1 is actually a triangle. Let us find the triangle's area. If this is 5, I mark the other side as well as 5, and this side, this length will be, what will be that length? That will also be 5. This is marked as 1 centimeter actually, so that will be 1. So now I write it here. What will be the S? S will be A plus B plus C by 2. So this is 5, this is 5 again, and that is 1. So it is 5 plus 5, 10, 11. So it is 11 by 2 centimeter. Either you convert it into decimal if you want the rest of them to be solved in decimal, or you can keep this S in fraction. I'm keeping this in fraction for the time being. Now area applying Heron's formula will be S minus A, S minus B, and S minus C. So that's giving me 11 by 2. 11 by 2 by multiplied by 11 by 2 minus 5. It will another 11 by 2 minus 5 it will be another 11 by 2 minus 1. Thereby making this 11 by 2 minus 5 is actually, I'm getting this as 1 by 2. This will also be 1 by 2. And this will be, I think, 9 by 2. Yeah. If we have to find the square root of this, becomes like 999. So this will be 2, this will be 2. So I'm getting the denominator as 4. And then I am getting this as 3 by 4 root 11. Root 11 I try is 3.32. So the whole thing is 2.49 centimeters square. This is the area of the first region. Let us find the area of the second region. That's a rectangle. I write here, I can make out, this is area of region 2. Region 2 is a rectangle, so it will be length into breadth. The breadth, if you see here, this one is 6.5 and this is 1, so it is 6.5 into 1, so that makes it 6.5 centimeters square. 6.5 square centimeter. Let's now move on to area 3. Area 3 sorry, is a trapezium, so it will be half sum of the parallel sides. So sum of the parallel sides, this being 1, this being 2, makes it 3. And the perpendicular height, we need to find the perpendicular height of this trapezium. Let me just make it okay. Now if you look at this small triangle, I'll just highlight this one. We can apply Pythagoras theorem to find that red altitude. So that will be calculated as I'm doing it here. It can be calculated as 1 square minus this side. Now what is the length of this side? The whole thing is 2, right? And the middle part which is given, this is 1. So that means rest of this and this have to be equal and divided, 1 equally divided. So each of them is 0.5. So what I'm getting is 0.5 whole square. This is root over. So it is 1 square. I have to find actually, 1 square minus 0.5 whole square, that's giving me 0.75 root over 0. I need to, okay, 0.75 root over. I'm getting at 0.87 if I actually rounding it off. Let me just check it out again. Yeah, 0.87. So area of, oh, I made a mistake here. This is area 3. Yeah. So it is now going to be 0.87 into 3 divided by 2. That's giving me 1.299, and I round it up to make it 1.30 centimeters square. Let's now move on to find the area of 4. The region area 4 also forms a right triangle. This side is 6, this side is 1.5. Even area of the region 5 will be same. So we can make out area of, I write region 4 and 5 will be twice of the same thing. Area of region 4 and 5. So it will be twice of half base, that is 1.5, and altitude, that is 6. So it is 3 into 1.5 multiplied by 2, that's giving 9 centimeters square plus 4 and 5. If we add all of them, like this is for 1, this is 2.49 for area 1, then it is area 2, this is area 3, and area 4 and 5 will get the whole area of the paper that has been used. And if I do so, I think I'm getting 19.29 centimeters square. I hope you followed this. Let us now move on to another question. Let me again write this question first. Yeah. Says the rhombus shaped field has green grass for 18 cows to graze. If each side of the rhombus is 30 meter and its longer diagonal is 48 meter, how much area of grass field will each cow be grazing? Let us draw. It says there is a rhombus shaped field. Let me draw a rhombus shaped field. Oh, it doesn't look like me. This is a rhombus shaped field. The longest diagonal, each side is 30 meter, it says. Okay, I'll write this as 30 meters each. It also tells us that the longer diagonal, that means this one, is 48 meters. How much area of grass field will each cow be grazing? Let us find the total area of the rhombus. Then if we divide it by 18, that will give us the area available for each cow to graze. To find the area of the rhombus, we cannot apply the direct formula because we don't have the other diagonal. So again, we'll be applying the Heron's formula to find the area of the rhombus. To do so, we'll first find, because we'll first find the area of this side, this part and this part. Also you can say that these two areas are congruent, so once we find the area of one of those triangles, we will multiply it by 2. I'll name this as, suppose, A, this is B, C and D. So S will be, for suppose I'm finding for ABD triangle, S will be 30 plus 30, 60 plus 48, 108 by 2. So that is 6108, that is 54 meters. Now area of the triangle ABD can then be calculated as 54, then 54 minus 48, 54 minus 30, and then 54 minus 30 as well. Let us now calculate. This will be giving me some 54 into, this is 6, this is 24, that's again another 24. If I solve this whole thing, that's 54 into 6 into 24 into 24 is root over, I'm getting 432 meters square. That is the area of one triangle. If I have to find both the whole total area, I'll multiply it by 2, and that will give me 864. This is the total area been grazed by 18 cows. To find area available for grazing by each cow, So we find area for each cow is 864 divided by 18, so that's giving me 48 meters square. So 48 meters square of area is available to each cow. Thank you.